Hello everyone, my name is Finding Pepper, and welcome to episode 6 of the Paper Minecraft tutorial series. This episode we are adding breaking and placing blocks, as well as item drops when we break the blocks. So the block that we are able to place is the item that we last picked up from an item drop. Alright, let's get started. First, we'll need to go over to the assets project. Here we are, there's a link to this in the description. And grab the PMC6 sprite. You'll notice that here there is a list called tile data, and we already have this list. However, this is updated with significantly more information about each of the tiles, as well as a couple of new blocks. Just right click on this and click export. Now that we've got that, we can drag the sprite into our backpack and head back over to our project. Alright, grab out your sprite. Now, we don't actually need this tile data list that comes with this sprite, so we can delete it. And then just go into this tile data list, right click and click import. Choose the file that got exported from the list in the assets project. Now we can just hide this list for now. We'll look at it again later. And now we can go into the costumes and drag all the costumes from 2 to 15 into the tile sprite. And the rest we will leave here for now. And we can hide this sprite. Alright, let's start by doing destroying blocks. Now we need a way to keep track of how long we've been holding the mouse down. So I'll make a variable called mouse for all sprites. In the main loop, in our game loop, we can just change this variable. We'll get an if else, check if mouse down. If it is, we'll change mouse by 1. And otherwise set it to 0. So this way we can tell how long the mouse has been held down. Now in our tile sprite, let's make a variable called mouse index for the sprite only. This will hold the position of the tile that our mouse is over. Now we'll make a block called find mouse index, run without screen refresh, and put it before paint when I receive stamped tiles. We'll also go into our player sprite and grab the get tile at block and drag it into the tile sprite. Now in our find mouse index block, we'll get tile at mouse x, and then we need to add to that our camera x, and then our mouse y plus camera y. This is sort of the reverse of finding a object's position on the screen based on its position in the world. It's finding the position in the world based on the position in the screen. So once we've found our tile, we'll set mouse index to grid index. Alright, now that we've found our mouse index, we can draw the little indicator on the screen to show that that is where our mouse is. So after we crop our water, we'll check if grid index equals mouse index. If it is, we'll set our brightness effect back to 0, switch costume to cursor, and stamp. Let's run this. And before we do that, we need to change our data amount per tile to 12 when I receive start game. Otherwise, bad things will happen, because we now have 12 bits of data for each tile. And we can see we have a black square showing wherever our mouse is. Now you'll notice that this mouse cursor can target blocks that are through the floor from us that we shouldn't actually be able to reach. So let's change that. We'll go back into our find mouse index block. What we'll do is essentially start at our player. So essentially what we'll do is start at the position of our player and then slowly move towards the position of our mouse. And if along the way we hit a block, then that block will become the new position of our mouse. So let's make variables x and y for the sprite only. And these will hold where we are in that path. So set x to x of player and set y to y of player. But we need to know how many times we need to move to get to where our mouse is. So I'll use our temp variable to hold this. Set temp. Now the total distance we're going, at least in the x direction, is our mouse x plus camera x, so the world position of our mouse, minus our x variable. And now we're moving in increments of tile size divided by 4. So we need to divide the total amount we're moving by the amount that each increment is. And this left part with the subtraction, because we're doing subtraction, we'll use absolute value because we just want a difference. We don't want negative numbers. Then because we're doing division, we'll round the whole thing. Now you'll notice that we're only doing this in terms of the x. Now if our y is bigger than our x, then this means that we could actually skip over blocks. For example, if we weren't moving left at all, we were just moving straight up, then temp would be 0. So I'll get an if else, and I'll check if this value, abs of mouse x plus camera x minus x, so the difference in our start and end x positions, I'll check if this is greater than the y equivalent of this. If this is true, then we'll leave temp like this. If this is not true, then we need to switch these to y's. Now that we've found the amount of times we can repeat, we'll just repeat by temp. Each time we repeat, we'll change our x and y positions. We'll change x by the total distance we want to move, which is mouse x plus camera x minus x, without the else, because we might want to move in the negative direction. Then we'll divide this by the total amount of times we're repeating, which is temp, to get the amount that we move on this go of the repeat loop. Now we'll do the same for y. Change y by mouse y plus camera y minus y, also divided by temp. Once we've done that, we'll get tile at x, y, and then check if tile shape equals hash. If it is, set mouse index to grid index, and then stop the script. So if we find a solid tile, then we just stop there and set our mouse index to that position. And you'll notice, if we go to the get tile at block, that it uses the find property block, which itself uses the temp variable. And we're using the temp variable to store the amount of times we repeat, so we do not want to change it. So I'll just go to the find property block and duplicate what we have here, and I'll take it over to our get tile at block, then remove the find property. Now we'll replace our tile index with the grid index, and the number with 2. Then we remove the set temp, and just set tile shape to this value. Now let's run this, and you can see that our mouse pointer seems to be just fine over here, yet when we look down at the ground, it only selects the tile that we can reach, the surface tile. Awesome, this is looking great. Now we can code breaking. So I'll make a new custom block called check break. Run without screen refresh, and I'll actually put what we have here into the check break block, and put the check break block in their place. Now let's check if our tile is solid. Find property number 2 of tile at grid index, and check if tile equals 2, meaning it's air, or temp, which we return from this find property block with the tile shape, if temp equals tilde, meaning it is a water tile. And then I will put a knot around this. So if it is not air or water, then it is a tile that we can break. Then I'll check if mouse is greater than, and then here we need to put some value, which is the amount of frames it will take to break the tile. So I'm going to show the tile data list, and you'll see data number 10 is our hardness. So we can find property number 10, tile at grid index, and then if mouse is greater than temp times 25. The hardness values in the tile data list are rather small, so we need to make them a bit bigger. If this is true, we'll replace item grid index of grid with 2, air. And back in the paint block, I realized I hadn't actually set the tile variable. We'll set tile to item grid index of grid, and then switch costume to tile. Then also in the crop water block, we can replace all instances of item grid index of grid with our tile variable. Not sure why I didn't do this before, but yeah, this is just a bit nicer. And I have to do that because I'm referencing our tile variable here in the check break block. Let's run this. Let's try and break like this leaf or something. That looks good. Now we can break the ground, and you'll see if we hold down our mouse, it does get broken. Now let's draw a little animation for the tiles getting broken. Around this whole thing, I'll check if mouse is greater than 0. Just so we don't draw the animation when we're not holding down the mouse. Now let's look at the names of our break costumes. These are all called destroy stage, and then a number between 0 and 9. So we can switch costume to join destroy underscore stage underscore, and then 10 divided by temp times 25, and then we multiply that by mouse. So our 10 divided by temp times 25 is the fraction of 10, which is how much one frame of mouse press would destroy it, and then we multiply it by the amount of time we've been holding down our mouse. Now we're going to take the ceiling of this to get it to be an integer, and because we know our mouse is going to be greater than 0 here, this will always be a number greater than 0. So we're going to then subtract 1 to get it to be a number between 0 and 9. Now we do have division here, and temp could be 0. The blocks which can break instantly, like grass and flowers, have a hardness of 0. And division by 0 does not result in a valid number. So there is the chance that this costume is not a valid costume. So we'll check if costume name contains destroy stage. And if it does, then we can stamp. So we only stamp the costumes which are our destroy stage costumes. Let's run this to try destroying a block of grass. And there you go, you saw that. That looked nice. And destroying grass and stuff does work. Now let's try destroying multiple blocks. Now after the first block, we can destroy the others instantly. And that's not good. That's because we are not resetting our mouse variable when we change what block we are selected on. So let's code it so that when we change what block our cursor is on, it will reset our mouse variable. I'll go to when I receive stamp tiles when we call our find mouse index block. Now we need to keep track of the mouse index before we use this block, and we already use our temp variable inside the block, so I'll make a new variable called temp2 for the sprite only, just a second temporary value holder. So we'll set temp2 to mouse index. And then after find a mouse index, we'll check. If not, mouse index equals temp2. Then we'll set our mouse to -1 actually. So resetting it. So you can see that that is working as intended. Great. Now that we've got breaking done, we can code our item drops. So make a new sprite called item. Now this could be most of our blocks here. There is some renaming we need to do so that our costume names match the names of their names in the tile data list. I'll change this grass block side to a grass block. Then this one will be just grass block underscore forest. The grass green will just be grass. Tall grass will just be tall grass bottom without the green. Same for the top. The fern will just be fern without the taiga. Same with the large fern bottom and large fern top. We just remove the taiga from them. And then cactus, we remove the side, and that should be it. So drag some of these costumes into the item sprite. We'll start with off-screen fix. We don't need air, but then grass block, dirt, stone, deep slate, and bedrock we will want. We don't need any of the water tiles, or this grass block forest. But we do want sand and sandstone. We do not need the snow grass block because that's another variation. But we do want our flowers, our grass, we do not want our dense leaves or our leaves in front of a log. However, we do want our normal log and normal leaves. And we don't want any of our water crops or our destroy stage costumes or cursor. But we do want the cobblestone and cobbled deep slate, but not these last two grass blocks. Now go into the asset sprite and drag all the costumes from 16 down to 28 into the item sprite. Alright, we can now hide the item sprite. Keep our asset sprite though. We don't want to delete that yet. And we can delete costume 1 of the item sprite. And we actually don't need the rosebush bottom. We can just keep the rosebush top, and I'll remove the top from it. So it's just rosebush. And then same for the peony and the lilac. As well as the tall grass and the large fern. Alright, now we need a list, and I'll call it item drops for all sprites. This list will allow other sprites to add item drops, which then the item sprite will spawn. So each time they want to spawn an item, they'll add 4 entries: the item, the X of the item, the Y of the item, and the amount of item. But yeah, I'll delete these. For now, let's just, when I receive start game, delete all of item drops. Now in the tile sprite, make a block called drop item and then an input tile. Run without screen refresh. So this will drop the item that should be dropped when the given tile is broken. Now if tile is less than 3, it's probably air, so it shouldn't be broken, so we'll just stop the script. If it is water, then it also should not be dropped. However, we don't actually know the tile index of this tile, which is required of our find property block. So I'll make a new custom block, find property number, and then an input number of tile, and then input tile. Then we'll duplicate this and replace item tile index of grid with our tile. Go back to our drop item, and I'll actually make this, I'll just say of, so it's a little bit clearer which one we're using. Find property number 2 of tile, and then if temp equals tilde, then also we stop the script. So if this is a fluid tile, then we do not want to drop it. Now we need to know how many of an item to drop. If we look at our tile data list, data number 8 and 9 is drop amount min and drop amount max, and 7 is the item that it drops. So we need to find both of these properties. So I'll start by finding property number 9 of tile, and now I want to be able to store both of these, so I'll use my temp2 variable. I'll set temp2 to temp, which is the return of a find property block. Now we can find property number 8 of tile. So now temp holds the minimum drop amount and temp2 holds the maximum drop amount. So I'll repeat pick random temp to temp2. Now, as a sort of shortcut for writing these drops in the tile data list, I'm saying if drop amount min and drop amount max are blank, it will just drop one of the given item. And if the item itself that it drops is blank, such as with dirt here, it will just drop the block that it is. So if temp and temp2 are both blank, then this will always be 0. But we would like it to be 1. So we can add to this a boolean of temp equals blank. And remember, if a boolean is put into a number input, it will return either 0 or 1. So if this is true, it will add 1 to the amount of times we repeat. Now we can find property number 7 of tile, and that is the drops. Now, as I said before, if drops equals blank, if temp equals blank, it should just drop the item with the same name as it. So we'll find property number 1 of tile, which is the name, and add temp to item drops. If temp is not blank, then we'll also add temp to item drops, but this is before we found property number 1. This is still the temp from find property number 7. This can be a bit confusing when the value of temp changes a lot, but hopefully you understand. Now we still have 3 more values to add to item drops. To find our x and y, we can make a new block called find position of tile at index. and then an input grid index. Run without screen refresh. We can set x to the floor of grid index divided by world height, because each time we move right in the grid, we change our index by world height. And then we need to multiply this by tile size to get the x position in terms of world coordinates rather than grid coordinates. Then we're also going to add half a tile to this, so it spawns in the middle of the tile rather than at the corner of a tile. And then for the y, we can set this to grid index mod world height. So once we've divided our grid index by the world height to get our x position, the remainder is our y position. Then this time we want to subtract 0.5. Okay, so back in our drop item block, we can use this new find position of tile index, our grid index. So find position of tile at index grid index. Then we can add x to item drops and add y to item drops. Then our count will just be 1. Add 1 to item drops. And that is all for our drop item block. Now in our main loop, I'll make a new broadcast for move entity. And I'll do this after we move our player. So make a new message, move entity. And also a new message called stamp entity. And stamp entity comes between stamp tiles and stamp player. Alright, in our item sprite, we'll make new variables. Item for the sprite only, x for the sprite only, y for the sprite only, and count for the sprite only. And you'll notice these correspond to the four things that get added to our items drops list. Now, an item of the empty string will signify that this item is not a clone, this is the main sprite. So we'll set item to the empty value when I receive start game. Now when I receive move entity, we'll check if item equals blank. If it is, this is the main sprite and its job is to spawn clones. So I'll make a block called spawn items. Run without a screen refresh, and I'll put it here. Then we can stop the script afterwards. Okay, in spawn items, we'll repeat until the length of item drops equals 0. So we spawn all the items in the item drop list every frame. We'll then set our variables. Set item to item 1 of item drops, x to item 2, y to item 3, and count to item 4. Then we'll also give this item some speed. I'll make variables speed x for the sprite only and speed y for the sprite only. I will set our speed x to pick random -10 to 10 divided by 5. So this will actually be a number between -2 and 2, but it gives us a little bit more variation in terms of there can be some decimals. Then we'll set speed y to pick random 50 to 30, also divided by 5. So it will always have some upward speed. Now we can repeat 4 times, delete 1 of item drops, and then we create clone of myself. And we need to make sure to set item back to the empty value when we are done with this loop to make sure that our main sprite does not become treated as a clone itself. So you can see that after one iteration of this loop, it will loop again with new items at the beginning of the items drop list. Now these items do obey collision, so I'll go into the player sprite and drag some blocks into the item sprite. I'll start with our find property number, then get tile at, then handle collisions at, then handle all collisions in direction, then move x, and then move y. So we have them all in a big pile here. Let's just separate them out. So I'll just go through the blocks and modify them slightly. For the move x, I'll replace this with a set speed x to speed x times 0.9, just slowing the item down a bit. We can remove this whole bit about dir and frame, And yes, we can delete the frame and dir variables. Now in our move Y, we can delete the part about if key space pressed, and then also this part down here about falling. Then we can delete the falling variable. For our handle collisions in direction, we only need to do the 4 corners, not the middle, because our items are rather small. So just leave these 4 checks. Our width and height we can set when I receive start game. Set width to 10 and set height to 10 as well. If you didn't delete the frame variable, that's great. If you did, that's fine. We'll just make it, again, new variable frame for this sprite only. And when I receive move entity, I will change frame by 1. Then we can use our move X and move Y blocks. Now for displaying, I will get when I receive stamp entity, make a block called stamp item, run without screen refresh, and we'll only want to do this if item is greater than the empty value. So if this is a clone, and then we can hide after we stamp because we already stamped. So here we'll start by just switching costume to off-screen fix in case we need to go off-screen. Then we'll do our standard scrolling positioning. Go to X of X minus camera X and Y of Y minus camera Y. Now I'd like for our items to bob up and down a little bit. So I'll change Y by the sign of frame, and then to make this a bit more substantial, I'll multiply frame by 5, and then I'll multiply our final result by 5 as well. And sign creates a wave when it's graphed, and that's why it causes the bobbing effect. Now we'll switch costume to item. And finally, stamp. Let's try breaking a block. Nothing happens. I realize that that's because I have not used my drop tile block. So in the tile sprite, in our check break block, I will just drop item tile. Okay, now we can run this. And look, we have a little block of sand bobbing on the ground. That looks good. Now let's code scripts to allow our items to be picked up. I'll make a block in the item sprite called check pickup. Run without screen refresh, and I'll put it in move entity after we move X and move Y. Now here we'll check if touching player, and if we are, we'll play a short animation that shows the item getting smaller. We'll change size by -10, and then in an else, we'll check if size is less than 100. We'll also change size by -10. Let's try just setting our size to something small here, like 10, and it gets set to a larger size, because the costumes are rather small. Here, I'll set it back to 100. We'll switch costume to off-screen fix before we change our size. And we should do the same thing down here where we also change our size. Now after this, we'll check if size is 30. And if it is, we will delete the clone. So when the item is small enough, it gets deleted, and then it will also get picked up. So make a new variable called selected item for all sprites to hold the current item that is selected. I'll set this to the item variable here, right before we delete the clone. So when we pick up the item, we set our selected item variable to its item. Now in player, in the reset block, we can set selected item, and then you can just choose an initial item to be selected. I'll say like dirt maybe. Now also in the item sprite, when I receive move entity, we can only use the touching block if we are shown. So I will show and just switch costume to some square block. Let's use the grass block. And then we'll go to X of X minus camera X and Y of Y minus camera Y, just to make sure we are positioned correctly. We can do a similar thing for the player, except for the player we need a hitbox, which we have in the asset sprite. We'll grab the hitbox costume into the player sprite. Now when I receive move player, we can switch costume to hitbox and show. And we'll also go to X of X minus camera X and Y minus camera Y, just so we position correctly. When I receive stamp player in our display player, we can hide. We'll just do that up at the top here because we can stamp even when we're hidden. Now we can show the selected item variable. Let's try breaking a block, then going and picking up the item, and we see our selected item gets changed to sand, and the item disappears very nicely. Alright, this looks good. Now that we have our selected item, we can code scripts to be able to place it down. So back in the tile sprite, let's find our check break block, and I'll rename it check break / place. Now you'll see here around the breaking script, we're checking if this is not an air or water tile, and then only breaking the block if it is. Now if it's an air or water tile, then we would want to place a block. So we'll change this if to an if else, and in the else, we'll switch costume to selected item. Not all items are blocks, so we want a way to figure out if this item is placeable or not. So before we switch costumes to selected item, we'll switch costume to our off-screen fix, and then after we do this, we'll check if costume number is greater than 1. Because if selected item was not a valid costume, we would not have switched to a costume after the off-screen fix, so our costume would still be the off-screen fix, which has a costume number of 1. So if the costume number is greater than 1, that means we did switch to a costume that was selected item, meaning selected item is a valid costume, we can place it down. So we'll replace item grid index of grid with costume number. And around this whole thing, we'll check if mouse equals 1. To make sure this is the first frame we press the mouse. We'll also set mouse to a large negative number, say -9999, after we do this, so that we have to release our mouse and then press it again if we want to be able to start destroying the block that we just placed. Let's run this and try clicking somewhere in the sky. You should see a dirt block appears. If you hold down, you won't be able to destroy it, but then you can destroy it. And you don't immediately replace it with the dirt block, so that is all looking good. Here's some seeds, and we should not be able to place this down. We can place our flower down, that's good. Let's see what happens if we place it in the air. Yeah, it just immediately disappears, and it does not drop the item. We'd like it to drop the item, I think that would be a good thing. So in update tiles, we can use our drop item block to drop item tile. And we'll do that in a couple places. The first place is the top where we have the scripts for non-floating items. Then the next one is down here for these two, the items that must be placed above or below certain blocks. So let's run this and grab this poppy here. I'll place it midair and then it drops itself. Let's try breaking one of our 2 tall flowers as well to see what happens. And we get a peony item. However, we can't actually place this down because our blocks are peony bottom and peony top. So in the tile sprite, I'll just make 2 new blank costumes, actually 3. One called Rose Bush, one called Peony, and one called Lilac. And let's remember these are costumes 129, 130, and 131. Now in update tiles, we can check if tile equals 129. And let's get our rosebush costumes 53 and 54. We'll replace item grid index of grid with 53, and item grid index plus 1 of grid with 54. Then for tile 130, we'll do the same but with 55 and 56. And then for 131, same but 57 and 58. Unpause the project. We should be able to place down our peony here. Great, now let's see what happens if we try to place a block where the player is. Then the player teleports up. That's not something we want to be able to do. We don't want to be able to place blocks where the player is. So let's go into our check break place block. After we check if mouse equals 1, before we do this, let's switch costume to normal square costume. So let's say the grass block. Then check around this if not touching player. So what we're doing here is switching to a hitbox of sorts, checking if we're touching the player, and if we're not, then we can place a block. Now we should no longer be able to place blocks where we are. Now let's create a little UI element to show what item we currently have selected. I'll use a new sprite and I'll duplicate the item sprite because we need all the costumes there. However, we'll just delete all the code. we can rename this inventory, because this is essentially what this is, just a one square inventory. Also, from our asset sprite, drag our selection sprite into the inventory. In our main loop, let's have a new broadcast for stamp inventory. And in inventory, when I receive stamp inventory, we'll switch costume to selection, and I'll set our size to 200, and I'll put this down in the corner. Now after we put it there, we can drag out a go-to block, and then stamp. Then we can switch costume, and then we'll use our selected item variable, and then we can stamp again. Then finally we can just hide. Let's run this, and we should see a dirt appear down in that little square. Yeah, now we have seeds. Great. Now we can hide our selected item variable. Now finally, let's add some sounds. I'll go into the assets project, and I'll take each of these and drag them into the tile sprite. And then this last one, the pop sound, will go into the item sprite. However, we should delete the built-in pop sound first, because this is a different pop sound. This sound is pretty easy to do. We'll do this one first. Our check pickup block, if size equals 30, we'll start sound pop. Now in the tile sprite, I'll make a new custom block called play, break, place, sound, effect. And then a number input for tile, and then a boolean, I'll call it place, question mark. And this will be true if we're placing a block and false if we're destroying a block. Run without screen refresh. Now I'll use this block once in our break script. The input will be tile, and then the boolean will not have anything in it, so it will be false. And then also in our play scripts. And the input will be our costume number. Now here in this block, first we'll find property number 1 of tile. Remember, this is not the of tile at. Then that will get our name, and we can check if temp, that's the return value of our find property block. If temp contains grass underscore block, we'll start sound grass1, and then stop the script. Now if temp equals sand, we'll start sound sand1 and stop the script. If temp equals deep slate, then we actually have two sound effects for this one. So we'll check if place, then start sound deep slate place 1, and else deep slate break 1. If it's neither of these three, then it's one of the default sound effects. And depending on what tool is used to break a block, that will influence what sound effect it makes. So let's look at our tile data list. Our tool is number 11. So we will find property number 11 of tile. Then if temp equals axe, we'll start sound wood 1. If temp equals shovel, we'll start sound gravel 1. If temp equals hoe, we'll start sound grass 3. And if temp equals pickaxe, we'll start sound stone. Now for our insta-break ones, we'll find property number 10, that's the hardness. And if temp is less than 0.1, we'll start sound grass 3. Now if it's none of these, we'll use the stone sound as a default sound. Alright, let's run this. Let's try breaking grass block. That looks good. Leaf blocks sound right. Let's try picking up an item. Then it makes the pop sound effect. And our sand as well. Now there's one last thing I'd like to do before we end the video, and that is to merge all of our grass blocks into this one grass block tile and just have it change its appearance rather than the tile number in different biomes. So first we need to edit our generation. We'll go into add column to grid. Let's just go over what we have here. First we spawn our bedrock, then the deep slate, then stone. Then when we get here we spawn the surface materials. What we have first is the water stuff. We don't need to worry about that. Then we have a desert. We shouldn't need to change that because there's no grass there. Here we have adding dirt to grid. It's tile 4. Then only if biome is 1 do we add our 3 to grid. I'm going to move this outside of this if. And we'll add the same grass tile no matter what the biome is. And then we can remove the 40 from number 2 and the 43 from our final last check where we do the taiga stuff. Now in the taiga we do want to add a layer of snow, which if we look is tile 129. So we'll make this if pick random 1 to 6 equals 1, and then inside here we spawn foliage, but if we don't spawn any foliage, then we can add a 129 to grid, which is our top snow tile. Now let's go into the tile sprite, find our animate block, and we can just do it in here rather than changing the tile number. We can say if tile equals 3, we can use our find position of tile at index, grid index, to get the x, y positions. And then we're going to use our x position and then look up its corresponding biome in the biomes list. We can use our temp variable to store this more easily. I'll set temp to item, and then this biomes list stores our biomes based on the grid coordinates rather than the actual coordinates. So we'll need to divide x by tile size and then take the floor of that so we can get an integer. Now we can check for what temp is. If temp equals 2, that is the forest, so we'll switch costume to grass block underscore forest. If temp equals 3, we'll switch costume to, this is the desert, so grass block desert. And if temp equals 4, we'll switch costume to grass block taiga. If temp equals 1, then it's just the basic tile 3 costume. If the block above it is a snow tile, then we want to switch costume to our snow block. So if item grid index plus 1 of grid, that is the tile above us, if it is equal to 129, which is our snow tile, we'll switch costume to grass block snow. Let's try this out. Here we're in a forest, and you can see the grass block is our forest color, and here we're in a taiga and we've got the snowy grass block underneath our snow layers and the taiga grass block where we don't have snow layers on top of it, which looks good. And you'll see we actually have a plains grass block over here on the very left. That's because the floor of x divided by tile size is sometimes 0. We need to add 1 to this because lists start at 1 in Scratch. So if we just run the project again, then that plains grass block should then disappear. Alright, great, that is looking good. It's just a small change, but I think it's good just to clean up our code in case we want to use anything specific to the grass tile in the future. And that will be it for this episode. I think we've done a lot of good stuff. This has made the game a lot more game-like, and it's not just walking around a world and doing nothing. So, hopefully you enjoyed this episode. Have a great rest of your day, and goodbye!